This is the second video for the 7.1b lesson. And the previous tables were a little different than this one. These tables state, some of it is the same. A, write the function rule as an equation using function notation. And B, using the words input and output, describe the function rule for the relation. And then side note, if the relation is not a function, explain why. All right, so this means that we now know that these are maybe not going to have a constant first difference and or are not going to be lines. So first of all, looking at this, we see that inputs are not repeated. So we should know right out of the gate that this is a function because there's not a 12 paired with two different outputs. So the next thing is I need to figure out what's the rule. And probably a lot of these will be lines because we spent the majority of the year studying lines. And so, like the last one, we might go with our margin constant first difference strategy in finding change in y over change in x. But if this doesn't stay constant, then it's not a line. And then we, I guess, have to kind of just sit and stare at it and think about it because we don't have too many other strategies. So 12 to -9 goes down by 21. -9 to 4 goes up by 13. 4 to -8 is down by 12. And -8 to 20 is up by 28. And this is why a long time ago when I did this work, I would always either do plus or minus next to these. This is down by 21. And let me change kind of how I wrote these. That's for these two. This is up by 13. This is down by 12. And this is up by 28. Oh, yeah. And in fact, all of these are equal to just 1 over 1 or 1. All right. So now I know that my function rule is going to be f of x equals 1x. And I know it's a line. And so this would be my x, 20. And then it changes to 15. So it looks like that's what, -5. And let's pick another easier one. 12 goes to 7. Yeah, so I'm going to say that this is -5. So we can look at it and maybe get it. Another way was finding where, when x is 0, what is y or f of x. Maybe that's in your table or you can work to that. Or another option, like in the first video, was to pick a point and plug it in. Any point will work, like this point. And plugging it in, -1 is y, 1 is x, sorry, 1 is m, 4 is x, and solve for b. Yeah, we can see that that works. All right, so now we're going to enter in our answer, which is, so part A, using function notation, it's x minus 5. And B, like in the other side, we'll kind of use the same sort of sentence, is each input is decreased by 5 to get the corresponding output. Okay. And now we're going to go to slide 11 and look at another example, which at this point you might be able to pause the video and just try this on your own. And first off, if we scan the inputs, we can see that none of them are repeated. So this is going to pass muster for being a function. If we notice that out of the gate, we don't need to answer any of this, and we just can describe why it isn't a function. We don't do all this other stuff. All right. So let's see what we got here. This one is going down by 5. This one goes up by 9, down by 13, and up by 11. This goes down by 15, up by 27, down by 39, and up by 33. And so all of these negative 15 over negative 5, and 27 over 9, and negative 39 over negative 13 and 33. All these equal 3. All right, so our function rule is f of x equals 3x plus, and again, you might be able to look at some of these as long as the m and b are not that tricky to identify, like testing it for this one. It looks like I'll need to increase it by 1, and then testing it maybe for this one. Yep, works for that one. Cool. There's our function rule, and then we'll describe it. Say each input is tripled and increased by 1 to get the corresponding output. And then on these last couple or remaining ones, you'll do the same thing. Before you go to doing too much work, remember that, and kind of hint, hint with this one, if you notice that it isn't a function, you can opt out of doing all of this and just describe why it is not a function. And then if it is a function, and you notice that it does not have a constant first difference, I wouldn't be too worried about like how do you do this. It's simply maybe becoming familiar with some of these, but there isn't a specific technique currently for this, which I'm almost directly hinting at slide 13 of how do I do this. Well, first of all, I'll give you a hint. It is a function because inputs aren't repeated. But if you look at your output column, those numbers should look familiar, which should hopefully guide you to figuring out this function rule.